Intelligent Video System Analysis is a general security system designed for human surveillance. It's a deep learning based project that can generate early alarms to inform the user before a possible disaster. Features that we want to implement were unsupervised child detection, weapon detection, fire detection, and unidentified human relocation detection. So, in the start, we decided to use a basic image processing tool like Hog, but the accuracy was not that satisfactory. After that, we use CNN ResNet and YOLO V3. Both of them were high accurate but were computationally expensive. In addition to that, we finally shifted toward faster RCNN Inception V2 because it took less time for training and provides state-of-the-art accuracy. Then we understood the working of each layer in faster RCNN. We self-generated and self-labeled the dataset for this model with the help of label image tool. Using this, we achieved a very good result, and at the end, we successfully trained the TensorFlow model to detect child fire human, as you'll be seeing in the videos ahead.
So previously our dataset was biased majorly toward fire and weapon dataset, while a moderate proportion of the dataset was biased for child and human dataset, which led to the trained model with less accuracy for correct recognition of all four objects. As per the direction of FIP panel, we were suggested to shift our core focus on large child detection. To achieve this objective, we had to divide our problem into subsections. Our two major focuses right now is to save maximum computational power for multiple camera deployment on a single system and training a robust faster RSTNN model that can detect with pretty good accuracy. Furthermore, we wanted to enhance the performance via code. For that, we decided to use a lighter weight motion detection algorithm which can detect any recognizable motion. This motion detector will pass only the required frame to train model for classification. Previously, our faster RCNN model was processing all the frames from the live feed, which made it computationally expensive and using 100% of resources all the time. We wanted our project selling point to be lost child detection. For that, we needed a large data set for correct classification. So we collected 2000 more images of weapon, fire, and children, and then we labeled them to retrain our model for getting higher accuracy. Now coming towards the demo. Here you can see that the live feed is first processed by the motion detector. The red box shows the area where the motion is detected. Then we only pass those frames in which the motion is detected to train model. We just added this red box to show you that the model is getting only those frames in which the motion is detected. So when it detects a fire in an image, it takes some time to send an email. So let's check. So here we get an email with the image attached to it in which the fire is detected. Same is the case for weapon. Whenever it detects a weapon in a frame, it will send an email.
In the previous section, it was shown that how the program will react in emergency situations like detecting fire or weapon. The whole mailing system, motion detection pipeline, and gathering of extra images was covered in first 7 weeks prior to lockdown. After the start of lockdown, our whole team considered various factors affecting our project, and we came up with a written document where our project was broken into sections, where first we have to complete each section and then integrate all the parts into one program. After integration of each section, we will now have to test it with camera feeds. Now coming towards the practical implementations in lockdown period, basically the most well-defined featured rich section for detecting and identifying a child and parent was by assigning some ID. For example, ID 1 and ID 2. So based on that, both of them can be distinguished. Now as you can see in the demo that the ID has been assigned to both of the subjects in the frame, and even when the subject leaves the frame and re-enters the frame, the same IDs are assigned to them. And even if we change the camera angle, the system is still able to detect the IDs. Now coming towards the conclusion. Now the major issue that we are facing is regarding the internet. We have to test large size models before proposing a possible module integration. Our project is data intensive and some members don't have good internet, which sometimes bottleneck our project progress. Workflow during the lockdown period is for development of the modules and integration of the modules. And workflow after the lockdown period is testing the whole developed solution and tweaking the modules if required in the testing sections.